Buried 4,850 feet underground in an abandoned gold mine, scientists are attempting to solve some of the biggest mysteries in our universe. They're hunting for something so elusive that they have to build massive detectors the size of Olympic swimming pools just to catch them. And if all goes according to plan, this mega science experiment could answer some of the deepest questions in the cosmos, including why we're all here. They're looking for time-traveling particles called neutrinos. To explain what neutrinos are and why thousands of scientists from around the world are studying them, we need a neutrino hunter.
Neutrinos are tiny particles in the electron family. They are extremely light and they don't interact, they don't hit much at all. So for the most part, they pass right through us, and they're very abundant.
So abundant that right now, there are 65 billion neutrinos passing through you without a care to your existence. They're considered fundamental building blocks of matter, in essence, what we're all made of, and they're part of something called the Standard Model.
The Standard Model is to particle physics like the periodic table is to chemistry. It's comprised of these 12 building blocks of matter and the particles that help those building blocks of matter talk to each other through the fundamental forces of nature.
They're also at the heart of one of the greatest mysteries in physics today, which is why, after the Big Bang, did we come into existence?
The Big Bang was basically a huge bath of energy, and as it cooled and as the universe expanded, particles were formed. When they meet, they annihilate again into a puff of energy. And this is great because it conserves all of the laws of nature.
But in those moments after the Big Bang, matter won over antimatter, so something weird happened.
There was some process where there was an imbalance between how matter and antimatter was formed that left us with the tiny bit of matter that we see in the universe.
And some physicists think neutrinos might be the culprit.
We're looking to see if neutrinos somehow behave differently that would cause this imbalance in the universe. Said very succinctly, we're asking, are neutrinos the reason we exist? I love saying that.
The field of neutrino detection is having a major moment. Physicists are constructing ambitious experiments in exotic locations to up our odds of catching them from sources like
cosmic ray showers that are produced in the upper atmosphere. We can make them in nuclear reactors. We can make them in particle accelerators on Earth.
And these neutrino detectors are marvels of extreme engineering. There's IceCube, a neutrino detector buried over 2,000 meters underground in the South Pole, Super Kamiokande in Japan, a detector with 50,000 tons of ultra-pure water sitting underneath a mountain, Snow Lab, located in an active nickel mine in Canada, and finally KM3Net, which is located at the bottom of the Mediterranean Sea. And the latest neutrino detector that just broke ground is DUNE, the Deep Underground Neutrino Experiment.
DUNE is by far the biggest neutrino experiment that's ever been undertaken in the world.
The biggest because they're using a particle beam from Fermilab in Chicago to shoot neutrinos and antineutrinos on a wild 800-mile ride through the Earth to South Dakota, where they'll be detected.
Just to excavate a mile underground to build the caverns to house these detectors, we'll excavate 800,000 tons of rock, which is about the equivalent of the weight of 8 aircraft carriers. So building these detectors is like building a ship in a bottle. We have to build components above ground that will fit down the shafts that we can assemble underground.
South Dakota may seem like an obscure place for a billion-dollar neutrino detector, but it actually has historical significance. In the 1960s, a chemist named Ray Davis constructed one of the first solar neutrino experiments in a gold mine, which at the time wasn't considered a successful operation.
Ray Davis's experiment came up quite short, as if somehow the electron neutrinos were disappearing on their way from the sun to the homestake detector in South Dakota. I would say for a long time people didn't believe Ray Davis's experiment.
But eventually, Ray Davis was vindicated as physicists' understanding of neutrinos evolved.
We now have confirmed that electron neutrinos coming from the sun were oscillating to other flavors of neutrinos and therefore not showing up in Ray Davis's detector as electron neutrinos.
And those oscillations are key. Not only do neutrinos pass through matter with ease, they also have split personalities, or what physicists call flavors.
So neutrinos come in what we call 3 different flavors: electron neutrino, muon neutrino, or tau neutrino.
This is why neutrinos are so fascinating. If neutrinos oscillate, they must have some mass, and that is the potential key to understanding why the universe has mass to begin with. Dune will carry on Davis's legacy, tracking the way a neutrino oscillates or changes flavors when it interacts with atoms. And they're going to use liquid argon time projection chambers to observe them, which sounds like something ripped straight from a cartoon. Liquid argon time projection chambers are precision technology on a massive scale, capable of producing photographic images of particles as they travel through the detector. For instance, you can tell the difference between the flavors from the trail they leave behind.
While the electron bounces around and produces a shower like a ping pong ball, the muon is like a bowling ball, and it just travels straight through the detector in a long line.
The construction for Dune is a mammoth undertaking and won't be fully operational until 2027. The hope is that Dune could provide a more comprehensive understanding of the universe we all live in, or unlock a whole new class of physics, or both.
If history is our guide, when we take advantage of a newer kind of detection technique and embark on such an ambitious experiment, we are likely to find things that we didn't expect to find.
For more science documentaries, check out this one right here. Don't forget to subscribe and keep coming back to Seeker for more videos.